Dakota sharpened his finger.
Dakota, I told you 3 times already.
All right. Okay. We're going to talk about circles today. Circles have properties within them that we're going to discuss, and you've been exposed to these. It's just, so this should be mostly review, but we do need to discuss it just in case you've had difficulties with this in the past. In this circle, I have drawn the center of the circle. Let's go back. Can anyone, by raising your hand, not just blurting out, not saying I don't know or anything like that, can you raise your hand and tell me what the definition of a circle is? Not this problem, but just in general, what the definition of a circle is. Give it a shot.
It has no points.
It is entirely full of points. It's made up of points. It doesn't have any angles. Okay, it's circle. The definition of a circle is all the points equal distant from a given point. And that given point is called the center. The center of the circle is the point in which all of the points on the line are equal distant from. And that distance from the center of the circle to those points is called the class radius. That's right. So the radius.
You want to write it down?
This you do not have to specifically write down, but you can if you need to.
Oh, I don't need to.
Let's go to this third circle here. When you put 2 radiuses together, or if you say it this way, if you have a segment that is one endpoint is on the circle and another endpoint is on the circle and it goes through the center, that is called the diameter. And there's a relationship between the diameter and the radius in length. The radius is equal to 1/2 the diameter, or 2 radiuses is equal to the diameter. Okay, diameter is half, or the radius is half the diameter.
Radius.
Diameter is twice as long as the radius. You can say that either way. On this middle of this top row, you have your center of your circle, and you have this segment that doesn't go through the center. Its endpoints are on the circle, but it doesn't go through the center. What's that called?
Chord.
Chord. Right?
Aww.
It's called a chord.
Chord with a C.
Yeah. I always have to ask this question.
I'll get wrong.
What is that segment?
Chord.
What is this segment called?
Chord.
What is this segment called?
Chord.
Here's your center of your circle, so it's still a chord. Who makes the chords?
It's not in the center.
Who makes the chords?
Who makes the chords? The circle does, because nothing else can make the chords.
The car accords.
Oh, that's where you get Concordia at.
Who makes the vehicle that's called an accord?
Jesus.
Seriously, his name is Jesus.
Toyota.
Car factory. Chevy.
Honda.
Honda.
And Honda
And
viewers in Latin.
Honda
stands for.
This is kind of
symbol.
what Honda's symbol used to look like. They've changed it a little bit. They don't have the circle around it
We have
now.
a big
At
H.
least it's not bridge.
But this used to be. So Honda makes a chord.
Honda Accord.
It's a play on words. Huh?
I thought
Oh,
Honda
it's
like
not
comes out the new cars that are made out of cars.
All right, one
They
more.
use, like wires.
Was
One
he
more
a
term.
mathematician then?
Him dad to get.
He's driving Prius.
Not right now. This bottom circle that I have drawn is up there because it is just simply representing the circle's edge, I guess you could say. The distance around a circle, Jonathan, is called
Circumference.
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 I spell that.
S-R-C.
S-I-R.
C-U-M. F-E-R-E-N.
Just do the best
So
you can.
it's like sir.
Circumference is basically perimeter. It is perimeter of a circle. But we use the word circumference to be more specific with circles. I need to add a page here to go over something.
Can we do clickers with this?
We are going to, yes.
Yes! Because they take a math class.
We're going to talk about, just more time for you to do homework. We're going to talk about area and circumference of a circle and how to find it. Let's discuss circumference first. How do we find circumference on a circle? I'm not talking formula yet. We'll write the formula down in just a second. But the idea of finding circumference comes from the relationship between a circle's diameter and its circumference.
The outside of it.
So if I take the diameter of this circle, and this is true for every circle. Yes, ma'am? Okay. If I take this circle, or this diameter, and I line it up here and I wrap it around the circle, it'd go to about here, then it'd go to about here, then it'd go to about here, and then there'd be this little bit left. What part of the diameter would that little part be?
The
Close. Which part of that number? 0.14, not 1.4. That little part is 0.14 of the diameter. How many times did the diameter lie on the circle circumference? 3.141592
pi.
356 times.
Pi.
And that's the little symbol of
I
the
like
song.
pi.
Okay.
Pi. Pi.
So the number pi that we use this symbol for, the Greek symbol pi, we use for the number 3.14. The number pi comes from the relationship, it's the ratio, so to speak, of the number of times the diameter of a circle lies on that circle's circumference. And it's the same for every circle. It doesn't work out nice and neat. We discussed this in test prep at the beginning of the year, that pi is an irrational number.
It's unending.
It does not end. They put that number, those relationships into computers and let them run, and just goes and goes. They've worked it out
The other
to,
day, like the billionth number.
they've worked it out past the billionth number place, I
How
think.
does the computer keep on
Or a
doing?
billion number places, decimal place.
How
It's
does
like
it?
the,
How
One
does
at a
the
time,
com-
raise your hand, please. I don't,
How does the computer do that?
they just do it, yeah.
is, kind of like the decimal
What the
version of.
Yes. That'd be, I guess, the way they think. So finding circumference. If pi is the number of times the diameter lies on a circumference, then circumference is going to be equal to the diameter, whatever this length is of your diameter. And I'm going to write it this way, don't write it down yet. It's going to be the diameter length, and that length falls on a circle how many times?
11.
Three times, 4 times. 3
Pi times.
3.1.
3.14 times. So whatever the length of the diameter is, you take that times that pi amount, 3.14, and that gives you the circumference. I want you to write this down though, because we're going to do something with it here in a second. The circumference is going to be pi d.
Pi d.
Pi d for diameter.
I can't draw the pi symbol.
I can.
Now just write this one down. Area of a circle is going to be pi r squared. R being radius. In my days of teaching, my many days,
Back in the day.
students quite often get confused about which formula works for area, circumference, they get turned around. So I had a student teacher, Miss Earls. I don't know if you guys would remember Miss Earls.
Is she nice?
She was here when you were 6th graders.
Oh, whenever I was in
Believe.
6th grade, I thought you were scared or something. I don't really go by that.
Still am. You just don't take me to screen. Just to keep you on edge. But she came up with this idea of this little chant that we're going to say in here to first of all get comfortable with what the two formulas are. So even if you have a moment where you're like, I don't remember what the circumference is or I don't remember what the area is, you can bring this chant in. And you learn by singing and chanting and things early in school, right? And so the chant was simply this, and you're going to do it with me here in a second.
Yes.
Get ready. It's pi d pi r squared. 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 Those are the two formulas that we're using for circles, either circumference or area. Now here's the added piece that I have thought can be helpful, is if you can remember the chant, pi d pi r squared, and you still don't know which one goes with which one, how do we measure area, dimension-wise?
Square.
Squared. So which one of your two formulas would go with area?
This second one.
Squared. Because we measure area in square dimension, and it has a squared. So if you can remember the chant, pi d pi r squared, you should know that the r squared goes with area because we're squaring that dimension. Then the other one would be the circumference.
Will I get a solo during this chant? Like, I'll just break out the guitar.
Area squares now. You like SpongeBob?
Oh, look, Isaiah read mine.
All right, the radius of a circle is 5 centimeters. Part A. What is the circumference? Let's do the chant here real quick. So we're pi d pi r squared. Pi d pi r squared. All right. Pi d is circumference. And I am going to allow you to use 3.14 on your calculator. I want you to type in 3.14. I did not want you on these problems using calculators typing the number pi because that's going to be off a little bit from what you get if you just use 3.14. But I am going to allow you to use calculators on your circle problems here for the arithmetic because I don't want you to fight arithmetic on this. But pi is 3.14. And then we're plugging in the diameter. If the radius is 5, Braden, what's the diameter's length? 10. We're going to go 10. And then we're multiplying by a power of 10, so this is easy math, 31.4 centimeters. And it's not squared because we're not finding area. We're finding circumference. So it's just the dimension itself. And again, you'll be able to use a calculator on that if you need to. B, what is the area? So we went pi d, pi r squared. Pi d, pi r squared. So area is pi r squared.
So 3.1.
And then it's not 10. So then we take the 5.
Isaiah asked earlier if you could listen to the rap, PEMDAS rap. We're not going to do that, but hopefully you'll remember that you have to do your exponents first. I've seen students regularly that will come through and take 3.14 times 5 and then square all that. But our order of operation needs to square the 5 first. Okay? That's what's in parentheses. We square the 5, that makes us 3.14. 3.14 times 25. And then we use a calculator for that. 3.14 times 25 is 78.5. And we're measuring that in centimeters and its area, so we square that. I'm going to skip this next thing real quick. We'll come back to them. Your assignment, problem set 60, 1 through 30, and it's going to be due Thursday because we have a test Wednesday. Alright, and we're going to stop the recording and then we'll go back and do the clicker. So front row, go ahead and go on up.